Let's begin with series arrangement of resistors. So for resistors that are in series, they are connected end to end in this manner. One terminal of one ends at the terminal of the next resistor after it. So here we have three resistors. I'm going to call them R1, R2, then R3. So here we have three resistors. So the resultant of these three resistors, or the effective value R, is going to be R1 plus R2 plus R3. Now, the meaning of this resultant or this effective value is a single resistor which can do the work of this R1, R2, R3 combined in this fashion. So it is a single resistor that can replace three of them and still do the job that three of them would be doing. So let's give them value. Let's say R1 is 2 ohms, R2 is 3 ohms, then R3 is 5 ohms. Then their resultant will be 2 plus 3 plus 5, and this gives us 10 ohms. So what it implies is that we can just get a single resistor that is 10 ohms. Then instead of having R1, R2, and R3 between this terminal, which you're going to call AB, we just connect a single resistor that is 10 ohms. So we just put a single resistor that is 10 ohms, and it will do the job of these three resistors here combined. So that is the meaning of this resultant. So that is series arrangement of resistors. Now take note of the way series arrangement is. One terminal of one resistor connects to the terminal of the next resistor, then the second terminal of that next resistor to the next one, and so on and so forth. Now if you observe the way these resistors are connected, you'll notice that R1, the first terminal of R1 comes to this node, the first terminal of R2 comes to the same node, the first terminal of R3 comes to the same node, and the second terminal comes to this node, this comes to this node, and this ends at this node. So that makes it a parallel arrangement. When all the terminals are at one end and the other terminals are also at one end, we call this node. You can call this node 1 and this node 2. So that is for parallel arrangement of resistors. So how do we find their effective value, their resultant? So their resultant, 1 all over R, is 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus dot 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 1 upon Rn if we have more than 3. That is, if we have n number of resistors that are connected in parallel. So we keep adding all of them, they are inverse in this fashion. Say our R1 is 2 ohms, our R2 3 ohms, and the R3 5 ohms. So let's work out their resultant here, the effective value, and see what we'll get. So let's divide this board into 2. So 1 upon R will be 1 upon 2 plus 1 upon R2, which is 3, plus 1 upon R3, which is 5. So for here, I'll look for LCM of 2, 3, and 5. And that should be 30. Right, 30 here. 2 divide 30, that's 15, times 1 here, we have 15, plus 3 divide 30, that's 10, times 1, 10, plus 5 divide 36, plus times 1, that is 6. So here, we're going to have, this is 25, so we're going to have 31 upon 30. So 1 upon R is 31 upon 30, and that suggests that R upon 1 will be 30 upon 31, which is 0.97 ohms. 0.97 ohms. Okay, so when resistors are in parallel, when they are connected in parallel, their resultant value, that's their effective value, is smaller than the least of them. The least of them here is 2, but their resultant, the effective value is 0.97. That is smaller than even the least of them. So when you do parallel arrangement, the effective value of the resistance decreases. So that is what we have there. Now we shall continue to this resistor network. Let's begin by labeling them. So let's call this R1, let's call this R2, let's call this R3, let's call this R4, and we'll call this R5, we'll call this R6, right? So we begin with R2 and R3. If you observe R2 and R3, they are their terminals. This hand is to this is to this, and this is to this. So that is a parallel connection. So R2 is parallel to R3. So we have to resolve to get their effective value. Similarly, R4 has this terminal ending here. R5 has this terminal to here. R6 the terminal to here, and the other terminals are also making contact at the next node. So three of them are in parallel. So we can say R4 is parallel to R5 and parallel to R6. So we're going to work out R2 and R3 in parallel, and we're going to work out R4, 5, and 6 in parallel. So let's begin with 2 and 3 in parallel. So since they are in parallel, we have established that the effective value is 1 over R upon 1 over R2 plus 1 over R3. This will give us the effective value of these two resistors. So 1 over R will be 1 all over 2 plus 1 over 1 because R3 is 1. So this will imply we have 1 over R equals, here LCM is 2. So 2 into 2 is 1 times 1 is 1 plus 1 into 2 is 2 times 1 is 2. So we're going to have 1 over R equals 3 over 2. So that implies that R, when we invert both sides, R is 2 over 3. So that is the effective value of these two. And we can leave it here in fraction. So let's work out the effective value of these three resistors here and see what we have. So 1 over R here is going to be 1 over R4 plus 1 upon R5 plus 1 upon R6. So 1 upon R will be 1 upon R4 is 3. So that's 1 upon 3 plus 1 over R5 is 5 plus 1 upon R6 is 5. So 1 upon R here, LCM of 3 and 5 is 15. So it's going to be 15. 3 in 15 is 5 times 1, 5 plus 5 in 15 is 3. So we have 3 plus 3 here. And that gives us, this is 6, this is 11. So we have 11 upon 15. And that gives us R to be 15 upon 11 when we invert both sides. So for these 3, their resultant is 15 over 11. For these 2, their resultant is 2 over 3. So let's redraw the diagram and see what we have. Let's take note of this before we move on. These 2, their resultant is 2 upon 3. These 3, their resultant is 15 over 11. The effective value of R2 and R3, we have gotten it to be 2 over 3, so that is this. So we just replace these 2 with a single resistor that is 2 over 3 ohms. Then these 3 here, we've got the effective value as 15 over 11 ohms. So that's just a single resistor. 3 of them becomes a single resistor, which is 15 over 11 ohms. Now we have a series network now that we can just simply add to get the effective value of the resistors. So we're going to get FR equals R1 plus R, which is this, plus R, this. And that will be R equals 4 plus 2 over 3 plus 15 upon 11. This is upon 1. So let's simplify this fraction here. LCM here is 33. Okay, 1 in 33 gives us 33. 33 times 4, that gives us 132, plus 3 in 33, that's 11. 11 times 2, that is 22, plus 11 in 33. 11 in 33, that's 3. 3 times 15 is 45. So we're going to have this to be equal to, we're going to have it to be equal to 132 plus 22 plus 45, that's 199 upon 33, and this will be equal to 6 ohms. So the effective value of the resistor in this network is 6 ohms. So all these resistors, their effective value is just 6 ohms. We're going to look at the effective value of this resistor network. So let's begin by labeling them. This as R1, this will be our R2, this is our R3, this is our R4, and this is our R5. Now, R2, R3, R5, R4 are in parallel as we have established in our previous example. So we're going to resolve R2. R2 is parallel to R3, parallel to R4. So these three are in parallel because their terminal are connected to this node and the other terminal are to this node. That makes three of them to be in parallel. And for resistor in parallel, we have also established that 1 upon R should be 1 upon R2 plus 1 upon R3 plus 1 upon R4. And that gives us 1 upon R to be 1 upon R2 is 3 ohms plus 1 upon R2 is 3 ohms, R3 is 4 ohms, then R4 is 5 ohms. So 1 upon R is going to be, we're going to look for LCM of 3, 4, and 5. So we're going to go with 60. 3 in 60 should give us 20. 20 times 1 is 20 plus 4 in 60 should give us 15. So here we have 15 plus 5 in 60. We'll have 12 times 1, that is 12. So 1 upon R is going to be, we'll add all this together. 20, that's 35. That's 47. So we have 47 upon 60. And this implies that R alone, when we invert both sides, will be 60 over 47 ohms. So these three resistors here, the effective value is 60 upon 47 ohm. So we're going to redraw this diagram here. This is our R1. Then that's for this. Then this is our B. So this is our R1, which is 2 ohms. Then this is going to be our R, which is 60 upon 47 ohms. Then this is our R5, which is 6 ohms. Now observe that R1, R, and R5 are in series. And we have established that for series connection of resistors, R is going to be R1 plus R plus R5. So R will be R1, which is 2 ohms, plus 60 upon 47, plus 6, that is R5, upon 1 upon 1. Now we simplify this fraction. This is 47. 1 divided 47 gives us 47, then multiplied by 2, we have 94. Plus 47 in 47 is 1 times 60. 60 plus 1 divided 47 still remains 47. And 47. Then multiplied by 6. That gives us 282. So our R value will be 282. This value plus 60 plus 94. And that gives us 436 upon 47, and that gives us 9.3 ohms. So the effective value is 9.3 ohms. We are asked to get the effective value of the resistance of this resistor. So we have two resistors here. Let's label them. I'm going to call this R1. Let's call this R2. This one R3 and this R4. So we have R1 and R2 series. We have R3 and R4 in parallel. Now remember again how you know when they are in parallel. One terminal of this comes to this node, one terminal of this to this, one terminal of this to this, and the second terminal to this. So there are two terminals are making contact, and that is parallel connection. So we can say R3 is parallel to R4, and we can proceed to get their effective value. So we say 1 upon R, which is the effective value, is going to be 1 upon R3 plus 1 upon R4. So 1 upon R is going to be 1 upon R3 is 5. So that's 1 upon 5 upon 1 upon 10. LCM of 5 and 10 is 10. So this is 10. 5 in 10 here gives us 2. 2 times 1 is 2 plus 10 in 10 is 1. 1 times 1 is 1. So we have this to be 3 upon 10. So 1 upon R is going to be 3 upon 10, and that implies that R is going to be 10 upon 3. Okay, so the effective value of these two is 10 upon 3 ohms. So we're going to draw this diagram from here. So this is our R1, this is our R2, and this is the resultant of these two here. This is point B, this is point A. So our R1 is 3 ohms. Our R1 is 3 ohms. Our R2 is 2 ohms. Then our R, the resultant of these two, is 10 upon 3 ohms. So we are in good position now to get their resultant, because now they are in series. So their resultant is going to be R1 plus R2 plus R, which is going to be 3 plus 2 plus 10 upon 3. So this is upon 1, this is upon 1. LCM here is 3. So 1 in 3 gives us 3. 3 times 3, 9, plus 1 in 3, that gives us 3. 3 times 2 is 6, plus 3 in 3, 1 times 10 is 10. So here we are going to have 25 upon 3. 25 upon 3. So let's see what that gives us. 25 upon 3, that gives us 8.3 ohms. So the effective value is 8.3 ohms. So the resultant of this network is 8.3 ohms. That's the resultant, and that's how you evaluate the resultant of resistor network.